Okay, let us start. How is your term 2 work? Have you got ready? Have you reviewed it?
No, I haven't started yet.
Huh? I thought a long time ago you should have started reviewing already.
No, actually the SEM 3 one also I want to focus.
Not much time left. Anyway, okay, let us carry on. 21 sound waves. Okay, let's look at. I hope you got your past paper. What are the common topics?
A common topic is propagation of sound wave and intensity. Actually, like everything, everything.
Yeah, can't predict everything. More like everything. Okay, let's just review what are the things you need to remember. Audio frequency is between 20 to 20,000 hertz. Sound waves are longitudinal waves. Compression are region of high particle density or high pressure. Reflection are region of low particle density or low pressure. And then the key thing to remember is displacement leads pressure by pi radian. So if that is your traveling wave in the x direction, then your change in pressure, right, is P naught sine omega t minus kx minus pi over 2. And then your P naught is the amplitude of the change in pressure. And all these terms you must be familiar. Doppler effect refer to the apparent change in frequency of sound when there is a relative motion between source of wave and observer. You can remember the picture there. Here the wavelength is shorter or frequency is higher. This part where the police car or the siren is moving away from the observer, right? Longer wavelength, lower frequency. So that is the formula you need to remember. F naught is the observed frequency. So choose positive when direction of sound. This one is for the moving observer, and moving observer with respect to the source of sound. So choose positive when the direction of sound and observer moving towards each other. Right? They're moving towards each other. Positive. Same thing here. And choose positive. Cannot see. Let me just take it up. Okay, choose positive when the direction of the sound and source are in the opposite direction. Right? In this case, lower part is Vs is the speed of source. So it means that the source is a police car, the siren. Right? It's moving away. Direction of sound and source in the opposite direction. Right? Sound is moving to the right. Source is moving to the opposite direction. Then you take it positive. Right? Where this one is the top is the observer. Observer moving towards the source. Then it's positive. Okay, V is the speed of sound. E is the speed of sound. F is the frequency of the sound of the source. Vs is the speed of the source. F naught is the apparent or observed frequency. V naught is the speed of observer. Then I need to remember this formula. Definition for power. Definition for power. Definition for intensity. and intensity is proportional to amplitude square. And if it's a point source, then definition for decibel, right? I naught, that's your sound intensity level. I naught is the threshold of intensity. Right? Usually it's given you this formula. I will not derive for you, but it's very easy. You just got a same source and then a distance A and distance B. So if it's right, intensity at A, intensity of B subtract is 10 log intensity of A divided by intensity of B. Okay, now you can use that. If not, it doesn't matter. You can use this formula, and usually this formula B is the wave phenomenon produced by superposition of two sound waves of slightly different frequency. Right? Usually we want the positive one, so we take the subtraction, the bigger one subtract the smaller one to get the big frequency. And for standing wave, closed pipe, right? Don't bother about that one. Just remember it's just opposite. That's the displacement distance. That's the antinode. That's the node. Right? Remember all that. How to get the wavelength. These are the wavelength are changing. The length is the same. Right? This one we look at the pressure changes with distance. So that is the antinode. That's the node. That's the antinode at center here, and that's the node there. Same open pipe. So in this case, the fundamental wavelength, fundamental frequency, remember that general equation, Fn, lambda n, then for your open pipe, that's the fundamental wavelength, fundamental frequency, general equation, node drop, antinode at the open end, node at center there, right? Second harmonic, or first overtone is the overtone there. That's your A, N, A, N, A, right? Okay, what is your answer for this one? When a sound wave travel in a medium, the displacement y varies with time t and position x according to the equation. This one is the equation. Which equation shows a variation of pressure in the medium? Yep. Ken?
Yeah, can answer.
Choice answer? Yep. I thought you said
My
Ken.
answer, yeah, Ken. Answer is boy.
Right? You need to know that the displacement leads the pressure by pi radian, half pi radian, sorry. So answer should be A. You are looking at the answer. You're not doing your own picking. Your answer given is B, but I think it should be A. Okay. This is a sine graph. This is a sine graph. The motion of the wave is to the left. Then right, you consider as a theta. Eta minus that is your cos. Okay, so that's what it means by displacement leads pressure by half pi radian. Okay now. Yep. Anything not clear? The key is this one. Displacement leads pressure by half pi. Yeah, Srini? Any comment?
The question, what is it trying to say? I don't get it.
You wanted to give you the displacement distance graph, then they want you to show how the pressure changes as the sound wave pass through. That's all.
Oh.
So the key is to remember this one. Displacement leads pressure by half pi radian. Okay, so that's why I say it's A rather than B.
Okay.
That's the derivation now. Which statement is true about electromagnetic and sound wave? What's your answer?
A.
Again,
A.
true, correct. Sound wave shows Doppler effect. Electromagnetic wave does not. That is false. Both show Doppler effect. Both waves propagate energy through vibration of particles. Not for electromagnetic wave. Electromagnetic wave propagate by variation of electric and magnetic field. Both waves require a medium for propagation. No. Electromagnetic wave can travel through vacuum. Okay, good. A. The propagation of sound wave in air in the positive x direction for the source is represented by the graph y against x below. Okay, that's a wave. Which graph shows the variation of air pressure with distance from the source? Okay, what is the answer? Yeah, you must do it at home, not come and do it in class. You are wasting your time here like that, paying me to sit with
Donkey,
you. Huh?
Donkey.
Okay. If you choose A means it's leading. Right? That's the reason why I give you the equation there. It's a minus cos graph. Okay, the key to remember, sorry, too many. Displacement leads pressure by half pi radian. Okay, so you look at that point, same point here and same point here. Right? That one, displacement lead that. That's how you look at it. So correct. B. An elastic string is stretched between two fixed points, which are separated at 2.6 meters apart. If the mass of the string is 0.15 kilogram and tension of the string is 30 Newton, what is the fundamental frequency of vibration that can be produced by the string? Okay. What's the answer? Right, that's a fundamental frequency. One loop. Yep. Calculate your speed using this formula. Right? Tension is 30. Mu is that mass there, divided by the length. That's the speed. And this is your half wavelength, equals to the length of the string. So you can calculate your lambda. Take a 2 across there. L is 2.6, 5.2. Then calculate your frequency. Frequency is your, take your lambda down. G over lambda. Put in your value. That's your speed there. That's your wavelength. So answer is B. Can.
Can check.
5. The guitar string has a mass L, a length L and mass M. If the frequency of the first overtone of the string is F, what is the tension in the string? Just playing only this one. Playing with the formula. What's the answer? Yep, what's the answer? Right, that's your first overtone. Must know how roughly it looks like. Can or not? Can or not? Fundamental mode. Sorry. It's not the fundamental mode. This is the first overtone. Okay, got must be either you can sketch it out or it must be in your head. This is your first overtone, 2 loops. So first overtone, that is your wavelength. And calculate the speed. Right? Wavelength is L, frequency is given, the frequency, and use that. Speed is square root tension over mu. So you want to find tension, square that. So you get V square, take the mu across there. Okay, T is V square mu. Put in your V, which is here. L square, F square. Mu is just your M over L. That's your answer. L cancel. Still got one L, F square M. Okay. Right? You must do your homework. If not, you won't learn anything. You just copy your answer only. Anything that's not okay.
So go back, sir.
Yep. What's the problem?
No problem, sir.
Okay, then go to number 6. Ali and Baba attend a musical concert. Ali brings a noise dosimeter and measures the sound level at 108 decibel from his seat. Ali and Baba sit at 10 meter and 5 meter respectively from the speaker. What is the intensity level of sound from Baba seat? Okay, what's the answer?
Answer, C, teacher.
Hope you really do it, not just look at the answer.
No.
Right? I is proportional to 1 over R square. Sound intensity level. Right? There's a threshold of sound, threshold of hearing. Right? 108. That's the intensity. Okay. Divide by 10. And take the anti-log. You get this answer. And remember from here. Okay. Take R square across there, you get a constant. So I square R2 square is I1 R1 square. So you want I2 is the new one, this is the new part, this is the old one. Or if this is Ali, this one is Baba. Then take your R2 down, that's what you get. So R1 is 10, that's the R1, that's the R2, 5. I1, you just take this one across, the I not across there, so this becomes I1. Okay. I0, then use your calculator, get the answer. Sound intensity level from the definition. Okay. This is your new intensity. Right? You're just using this formula. New intensity divided by I0. I0 cancel off. Use your calculator. Answer C. Can? Okay, let's go to number 7. The intensity level of sound at 50 cm from the point source is 65 decibel. What's the power of the sound produced by the source? Okay. What's your answer?
Boy je.
Okay, how do I start then? If you say it's boy.
Beta equals to 10 log I over I0.
Okay. From there, put in your 65. Put in your I0. This is your I0. And calculate your I. Then, after that, what formula to use? You are not doing your homework. You are just looking at the answer. That's all.
I told boy teacher, the answer showed
You told me
donkey.
boy, no point. I asked you what's the next equation to use to calculate your power, but you never answer. So it told me that you don't know. Right? R is the distance of the source from the point. Right? Cross multiply. Okay, what am I doing? I lost my I. Sorry. Okay, I'm just using this formula. Take that across there to find my power and put in your value. 4 pi. Change it to meter. And your I is this one. Okay, donkey. Okay. What should I do? Ali and Chong stand stationary at at P. Ali then runs away from Chong with a speed of 2 meters per second towards a vertical concrete wall. That's your wall. While blowing a whistle that produces a sound of frequency 500 Hz as shown in the diagram below. The sound produced directly by Ali superimposed with the sound reflected by the wall. What is the beat frequency heard by Chong? Okay, what should I do?
There is like two frequencies, so the formula FV over V plus U. So first one 340 times 500 divide with 342.
Where do you get 342?
Combination of V
there's a
plus
formula
U.
to use. Observed frequency, apparent frequency heard by Chong. Right? We are not looking at the top there. So that one is 0. We are looking at Chong. Observed frequency is 340 feet of sound. 340 feet of sound. And then there's your source. The source is moving. The source is moving away from the observer. So we choose it as positive. Times 500. We can calculate our F naught. And calculate the apparent frequency of the reflected wave. Right? Here we are dealing with the top. Right? This one is 0. Sorry. What am I doing? Oh, sorry. This is the apparent frequency of the reflected wave. So the reflected wave what am I doing? Oh, here the source is moving towards that's why we subtract. Okay, it's moving away from Chong, but it's moving towards the wall. So that's why we subtract here. Get 503 and subtract to get the beat frequency. Right? It's always a positive value. The answer is C. Okay.
Okay.
Doppler effect looks like quite popular. Okay, another one. An ambulance and a car move towards each other with a velocity of 20 and 10 meters per second, respectively. If the frequency of siren is 500 Hz, which is the relative velocity and apparent frequency of sound received by the driver. Yep. Relative velocity.
The answer is donkey.
What? Okay, how do I calculate?
Calculate the relative velocity first.
How to calculate relative velocity?
Speed of sound plus the velocity of the car.
Relative velocity of sound right? Relative velocity of sound, you have to speed of sound plus the speed of car. Right? They are moving towards each other, that's why we plus it up. There's a top there. We get 350 Okay, so the top we have calculated. And the source of sound and the car is moving towards each other. So we subtract. Okay. That's your F, that is 500. Donkey, okay. Anything not clear?
Clear, Che.
Yeah.
V0 is the car because the car is the nearest, right?
We know is the car that's moving, no? The car, the speed of the car, that's the speed of sound. They are moving towards each other. So you add the speed together, no? Speed of car, the velocity of car, and the velocity of the sound, no? Can. They are moving towards each other. That's why you add them up.
Okay.
And bottom one, we are looking at the ambulance because ambulance is the source. Right? The speed, the sound wave, and the source are the sound wave and the source are moving towards each other. Okay, that's why we subtract. Anything that is not clear? Okay, this one they are nice to you. They draw for you picture. Car X and Y are moving in the same direction with respective velocity shown. Is the driver of car X horn is the one that provides the sound with frequency 1000 Hz. What is the frequency of sound heard by driver of Y? Okay. What's the answer? Okay. Basically, all this formula, that's all. The top there, should it be plus or negative?
Negative.
We are looking at Y. Y is moving away. The sound is moving towards it. Negative, okay. How about bottom there?
Negative also because it is moving towards the same direction.
This one we are looking at the sound. The sound is going to the right. The source is moving to the right. So negative, okay. Move negative. Good. Okay.
Okay.
Now you can see a lot of Doppler effect coming out. Police car sounds is siren 500 Hz and move with constant speed 40 meters per second along a straight one-way road towards a speeding car. If the speed of car move at constant speed of 25 meters away from the car along the road, what is the frequency of the siren heard by the driver of the speeding car? Same picture as previously, same as this picture. Right? You can just imagine that. Okay, so same formula. Basic, remember the formula? The top there is the observer and sound wave. Should it be positive or negative? Yep. Top should be positive or negative? This one.
This one speeding car so negative.
So you are saying 320 minus 25. Am I right? 320 minus 25.
Yeah,
Okay, how about bottom?
definitely police car means that means it's chasing the fella. So that means of course also negative lah. It's moving in
Yeah,
the same
both are
direction.
in the same direction. The sound wave and the siren, which is the sound source, and the police car are moving the same direction, negative, correct? Both negative times 500 to get your F naught. 527. C. Okay, let's go to B and C. Right, anything that we can see from here? B and C, not every year lah. Right, not every year will come out. Anything popular? Nothing popular. Most topic can come out. Okay, not every year. Okay, a firecracker explodes in air at 10 meter vertically above a boy. The intensity level of explosion heard by the boy is 60 dB. Threshold is given. Calculate the power of sound from the explosion of the firecracker. What formula to use? What formula to use?
Alpha equals 10 log I over I naught.
To calculate what?
To calculate the I lah.
Okay, good.
Intensity.
Sound intensity level formula. Calculate the intensity. Put in your 60 and the threshold. That's your I naught. Calculate your I. Then
You want to find the power, so times with the I lah. So this, yeah.
what do you mean times is the R? What formula to use?
P equals to I over, I equals to P over 4 pi r square.
Okay, good. Right. From there, we calculate your I, and then your I equals to that. Then take a 4 pi r square the outside. Okay. Determine the intensity level of explosion heard by another boy 15 meter from the explosion site. Same as this one, except now you are going backwards to calculate your beta, that's all. So what should I do? The first step. Yep, what's the first step that I should do? Calculate I first, oh? Yeah, use the formula. You have got your P already. Put your P inside. Okay. Change it to power. And 4 pi. Distance is 15 square. Calculate out. And after you're done that, use this formula back again. No? Okay. Your I is this one. Threshold frequency is that one there. That's all. Since it's further, it should be smaller. Okay. Any comment? Anything not clear?
Clear, teacher.
Differentiate between propagation of sound and light.
Sound wave require medium for transmission. Propagate by oscillation of particle. Light wave can pass through vacuum. Propagate by oscillation of electric field and magnetic field.
Okay. Sound wave is mechanical wave, so need a medium to travel. Propagate by vibration of particles or oscillation of particles. Light wave is electromagnetic wave, so can travel through vacuum, propagate by oscillation of electric and magnetic field. Okay, good. Number two, two flutes produce sound with frequency 259 and 261 Hertz at the same time. Determine the bit frequency. What is the answer? How do I calculate the bit frequency?
How do F1 minus F2, that means 261 minus 259, the lowest, the highest
subtract,
minus the lowest.
Just subtract.
Straightforward.
What is your answer? A guitar string of length 63.5 cm is tuned to produce fundamental mode. Guitar string is just that. Fundamental mode is that of note
So it's
245
2L.
Hertz. Calculate the speed of wave in the string. So it's lambda equals to 2L. Calculate your lambda. Then after that, how to calculate the speed?
F equals to V over lambda. Lambda is 2L, so just substitute inside, then can find the V.
So your V is your F times lambda 1. The frequency is given. The speed you already calculated. Put in there, calculate out. Explain the change in frequency of the wave on the string if the tension in the string is increased. Yep. How to explain? What formula to use? So you want another class on Monday and Tuesday?
Monday, teacher. Tuesday also can lah. Monday is the public holiday.
Monday is a public holiday. Tuesday?
Tuesday, no.
Tuesday is not public holiday.
No.
What time do you want the class?
Monday, 9.
9 o'clock, okay. We can decide on Monday what time you want or Tuesday. Okay. Explain this one. Explain the change in frequency of the wave on the string if the tension in the string is increased. What formula to use or what reasoning?
V equals to square root T over mu.
Right? Explain the term used. V is the speed, T is the tension, mu is the mass per unit length. Okay.
Then
yeah. You have got the formula already. Then the next step is just your tension increase. Right? Tension increase. Same but that we have do the calculation. You can use the tension increase, the speed increase. Speed increase, then you can just go back to this formula. Right? Your speed increase. Lambda is constant. So frequency must increase. You can use this formula back again. That's all. That's the reasoning. Right? Lambda 1 is fundamental, doesn't change. Lambda 1 is constant. So speed increase, your frequency must increase. Right? If not, convert that off. V is V over lambda. Lambda constant. So as tension, the string is increased, the speed, and thus the frequency increases. Okay? Need to define your term now. T equals to tension. Anything? Any comment? Anything not clear? Yeah, cannot. Right? Any formula you use, you need to tell the examiner what does it stand for? Mass unit length constant as the same string is used. Okay or not? Okay or not? Anything not clear? If clear, let's go to the next question. Okay, let's go to section C. State two necessary conditions for the formation of standing wave. Okay. What are the two necessary conditions for formation of standing wave?
Must have same frequency and move in opposite direction.
Two waves must be traveling in opposite direction with the same speed and amplitude. Okay, a standing wave on a stretch string is represented by the equation. Right, there's an equation there where y and x are in centimeters and t in second. Determine the distance between two successive nodes. How do I do that? Yep. What should I do?
One y equals to a cos 2 pi x over lambda sine omega t.
Right, that's the amplitude. Right, must be able to identify this amplitude. When we come to node, we want to know that the node amplitude is 0. Right? I want A equals 0. So A equals 0 divided by 3 also will be 0. So it means that it must be to get cos 0, right? Cos 0, sorry, to get answer as 0, your cos must be pi over 2 or 3 pi over 2. Right? That means this one must be the same as that. Then you subtract. Distance. Right? Distance is basically I'm using pi and pi cancel off. So this is 2 divided by 0.1, which is this one. I'm just subtracting these two. I just simplify the step as well. I have to calculate my x for this one, calculate my x for this one, and then I subtract to find the distance between the node, right? Which is 10 cm. Can or not? Yep. Alternative, you can go and calculate your wavelength and your frequency, and then between node is just your between two successive node is just lambda over 2. That's the alternative. If you don't like a lot of maths, you should get the same answer. Calculate the speed of wave which form the standing wave. Okay, what should I do? Calculate the velocity of the wave which form the standing wave. Yep, what should I do?
What should I do? V equals to omega over k.
Say again.
V equals to omega over k. We already know what's the omega, 85 pi.
Omega over k. How do you get that?
This one I had to refer and I didn't know how to do.
Right? Omega, that's omega. Go back to refer to omega is 85 pi. And we compare it to pi f, your frequency. Right? And after that, go and find your wavelength. Right? That's okay. 0.1 pi. 2 pi over lambda. So find your lambda. And V is f times lambda. Okay, out. That's all. Anything not clear?
Clear, sir.
You can use this method to calculate your lambda. And then for a string, right, distance between two nodes is half lambda. You just take half of it. Half of this one is 10. That's why we get that. If you find doing the math is harder. Okay. Just put a note there. Right? Or right? That's the alternative method. If you don't like calculation. Okay. Any comment? Anything not clear? In fact, it will be faster lah if you use this method. Since you already calculate your wavelength, right? Here you already calculate your wavelength. Okay. If no question, let's go to the next step. A long tube has a tap. There's a tap. Feed to it. Fill with water as shown in the diagram below. The tuning fork of 5 Y12 Hz is sound above the tube as the water flows out slowly through the tap. The first loud sound is heard when the length of air column is 15.7 cm. As the water continues to flow out, the second loud sound is heard when the length of the air column is 48.1. Sketch the standing wave in the tube when the loud sound are heard. Okay. How should it look like? Any idea? If you want, you can draw. Funny, why you cannot draw? My student can draw. What should I do? You can try and see whether you can draw. Use your mouse, so if you are can draw for me. I want to see what is your answer. Can or not? Can or not? Yep. Can or not? Okay, it looks like you are not prepared today. That's all? That's the first one? That's the second one? Right? Antinote, note, antinote, note. At the center is your note again. Antinote here. What is meant by end correction? Okay. What is meant by end correction? You are not prepared for class, my friend.
End correction. End correction is distant from end of tube to the antinode lah. So that means the antinode is like a little bit above.
Okay.
From the end of the
Basic
tube.
idea is
So
the antinode is slightly above the tube, not at the end of the tube. So the end
slightly
correction
above the tube.
between the antinode and the top of the tube. Okay, good.
Hey, Chia, which one is the top of the tube?
This is the top of the tube, this part. The antinode is not here. Antinode is slightly above.
Yeah, it's a little bit up. Yeah.
That's the basic idea. Hey, what am I doing? Right? Antinode is usually slightly above the open end of the tube. The end correction is a distance between the antinode and the top of the tube. Determine the velocity of sound and the end correction of the tube. Yeah, what should I do? Basically, just doing that. Let this one go slightly above. Let the end correction be E or A, whatever you like. Yep, what should I do? What's the first formula to write? Yeah, L1. This is your half wavelength, a quarter wavelength. Quarter wavelength, you plus a bit end correction there because that's where your L1 is. And the second one is this one. L2 is slightly above there, plus the end, 3/4 lambda plus the end correction. Then you subtract to get rid of the end correction. L2 minus L1. L2 is given. This is your L1. This is your L2. Okay, just take this across there to calculate your wavelength. Then after that, use either equation to calculate your end correction. Right, from here, speed is f times f lambda. That's the lambda converted to meter, and then that's the frequency. The frequency. Okay.
Okay.
Oh, sorry, I've forgotten the end correction completely. Incorporate your end correction. What is happening? So end correction, we just use sorry about that. We need to calculate the end correction also. E equals to, I can use L1 or I can L2, doesn't matter. L1 minus your lambda over 4. Okay, I think I will let you do it yourself. That's all. Show you how to do that. End correction. Rather than waste time there, let's go to the next question.
Actually, can stop here. I can do the next question tomorrow.
Hey, we still got a bit of time. I know you're tired,
Okay lah.
but we need to complete it. Describe the propagation of sound in a piece of steel bar. Okay. Just about 10 minutes more, then we will stop. I know you are tired already. Right? Sound wave propagate through steel bar. The particles in the steel vibrate, forming region of compression and reflection. The sound wave propagate as region of compression and reflection. Distinguish between intensity of sound and sound intensity level. Can just take each of them. What is the intensity of sound? What's the intensity of level of sound? Memory work only, this one, definition. Intensity is the rate of energy falling normally per unit area. Sound intensity level is beta. I naught is the threshold of hearing. I is the intensity. Okay, that's all. If you want, you can add in decibel. This one is in watt per meter square. Not necessary lah. I think if you want, you can add it in. 1 mark for each. Audio system produce sound of intensity 80 dB. You can see the sound intensity level very popular. AB in section A, B, and C at a distance 55 meter. determine the intensity of sound at distance. Okay, what should I do? What should I do? What formula do I use?
What formula?
Um,
Log 10 I over I naught.
okay, use that formula. Put in your value. Beta is 80.
Then
That
find
is
the I.
threshold. Then find your I. Then after that, what formula do you use? Usually they ask you to define. So that's the other formula you need to use. Right? IR square. What am I doing? Oh, we have calculated that already. And calculate the intensity level of sound at 100 meters from the source. Okay, what should I do? What should I do? What should I do? Okay, I think you're too tired to think through already. Same thing, this is a new one. This is the old one. There's a new one. There's the old one. Okay, calculate backwards. So previously we calculate from here to I. Now we calculate your new I. That's the I2. Take this one down. That's why we get that. Put in your value. R1 is 55. R2 is 100. I1. That's your I1. Calculate out. And after that, use this formula. Right? Beta. I. This is your I. Threshold of hearing. Then use your calculator. Okay. I think we will stop here. We will leave the others 2D to tomorrow since you are too tired to concentrate. Anything you want to clarify?
Not sure.
Okay. If not, tomorrow I see you at 9 o'clock.
Okay, sir.
Anything else you want to ask or anything? If not, I will stop already.
Stop here, sir. Okay, thank you,
Okay.
sir.
Have a good evening.
I have a good evening, sir. Thank you.
Okay, I will end it now.
Bye.